Hello and welcome to the webinar, The Top 5 Technologies to Watch in 2024. My name is Anthony Schiavo. I'm a Senior Director and Principal Analyst at Lux, and I will be leading today's session. I will be presenting alongside 5 of my colleagues, Runil Dalia, Principal Analyst, Varsha Setharaman, Research Associate, Josh Hasland, Senior Director, Jessica Hernandez, Analyst, and Akshay Chaudhary, Analyst. These represent all the different areas of technology and research that we cover at Lux. So throughout this webinar, you could type any questions you have in the questions box on your screen. Time permitting, we will answer all the questions that we can. If your question does not get answered, please do not hesitate to email it to us at questions@luxresearchinc.com, and we will respond. And with that, let's jump into the presentation. Before we get to the top 5 technologies, I want to take a moment to just highlight some of the megatrends from last year that are really shaping the space in 2024. The first is, of course, inflation and finance. Inflation became a major concern last year in 2023, and banks responded by raising interest rates. This resulted in a real tightening of funding for a lot of startups and innovators in the space. Second, we have AI. It's been the hottest technology trend of the last year and probably this year as well. This man, Jensen Huang, is the CEO of NVIDIA. They recently became the most valuable company in the world. On the hype, maybe the bubble, the promise that AI will transform the world and that they can provide the chips for it. And lastly, geopolitics and geopolitical tension. In areas like electric vehicles, clean energy, chips, AI, even infrastructure, geopolitical tension has been defining the policy options on the table. We just saw recent tariffs from the Biden administration, for example, on a wide range of products from China. So this has been affecting and will continue to affect the development of technology going forward. So with these megatrends in mind, I asked each of these 5 analysts this question: what is the top technology to watch in 2024? And I told them this could be top for any reason. It could be the thing that they think is most impactful. It could be an early stage technology that's just coming out of academia. It could be something where deployment is really going to kick off in 2024. So with that in mind, I'd like to invite our first analyst, Runil Dalia, to talk about white hydrogen.
Thank you, Anthony, and hello to everyone on this webinar as well. So white hydrogen, what is white hydrogen? I don't think I need to explain why what the hydrogen economy is and why everyone is talking about it. And when it comes to the hydrogen economy, there's a lot of discussion, a lot of activity, a lot of investments being made in the production of low carbon hydrogen. And traditionally, these are green hydrogen, but also blue hydrogen from natural gas, or turquoise hydrogen also from natural gas. But this year, late last year and this year, we've seen increasing activity into a new color of hydrogen that is known as white hydrogen. So what is white hydrogen? White hydrogen is essentially naturally occurring hydrogen that is found underground. So that hydrogen is present and on paper can simply be extracted and used for energy or for feedstock purposes. Now that's on paper. The reality is that today no one has proven that there is a reserve of white hydrogen, of naturally occurring hydrogen, that can be cost effectively extracted from underground. Now, despite this, that hasn't stopped money pouring into the industry. As you can see here, there's quite a few companies already active in this space. So one particular company, Coloma, has raised over $400 million as an investment in order to find and extract that natural hydrogen. But today, not a single company has been able to do that. Now, the promises of white hydrogen are clear. White hydrogen is carbon neutral or low carbon. It does not come from fossil resources. White hydrogen is already in the gaseous state underground, which means that you only need to extract it. You don't need to convert water and electricity into hydrogen as you would with green hydrogen. You don't need to produce it from natural gas as you would with blue hydrogen and turquoise hydrogen. So on paper, white hydrogen has a promise of being the lowest cost form of low carbon hydrogen out there. However, today there's many challenges ahead, including extraction, including locating these proven reserves. And today, we don't believe that the hype around white hydrogen, that we don't believe that the $400 million that was raised for supporting white hydrogen, that these are justified. So right now, white hydrogen definitely monitor the technology, watch what's happening in the space, but don't take action yet because much of the promise of white hydrogen, none of it has been achieved so far.
So, Runil, what would be a tipping point or something that you are looking for to actually, change that take, change that opinion that would give you a bit more confidence in white hydrogen?
I mean, at the end of the day, when it comes to hydrogen, there's a lot of activity, across the different forms of low carbon hydrogen. For me, white hydrogen in particular, the tipping point would be where you see activity from oil and gas majors, the companies like Exxon, Shell, BP, Total, and so on. And the reason for that is because at the end of the day, white hydrogen is simply a gas to be extracted from the ground, and oil and gas companies know how to do that very well. They've been doing that for centuries with natural gas. Now, today, not a single oil and gas company has publicly disclosed that they would like to enter the space or that they're even considering entering the space. And until they do so, I don't believe that a startup like Coloma or the many other startups out there will be able to succeed. So for me, the tipping point would be when an oil and gas major anywhere in the world says that white hydrogen is part of their portfolio, they would like to initiate exploration for white hydrogen.
You mentioned a little bit about the need for, new seismic imaging approaches. What other technologies, or if hydrogen works, white hydrogen, I should say, works, what other technologies are going to be necessary? I know purification is a potential concern because we don't really know what the quality of the hydrogen is here. So maybe can you say a few words about that?
Yeah, exactly. I think the general idea is that all of the seismic imaging technologies that we have today for natural gas can be applied to hydrogen, but that is not necessarily the case because hydrogen is a very different molecule from methane. So you can't make the assumption that the techniques that we have today can simply be used for hydrogen. And this is something that many in the industry believe. The conversations we've had with some of these developers say something different. Now, once you have located the hydrogen, extracting the hydrogen, again, on paper, the techniques will be the same, but you have to adapt the extraction technologies to the much smaller molecule of hydrogen. And then purification also comes into play as well, because right now we don't know what other gases will be part of that white hydrogen reservoir. So it's very unclear right now what is the full technology portfolio that will be required to extract and purify that natural hydrogen, but definitely we will need to develop new techniques and new technologies for this.
All right, Runil, thank you so much. And I'd like to invite my second colleague, Jess Hernandez, to talk a little bit about vehicle to grid, or V2G, and what the impacts might be here.
Great. Thanks, Anthony. Happy to be here. Right. So as you mentioned, the technology I want to highlight today is vehicle to grid, or V2G. And many of you may know already that this is not a new innovation. Actually, the technology has been ready for a while, and there have been a few incremental improvements. But where we see the most action and why this is making the list today is because there have been a lot of activity on business model innovations to bring V2G to the market. There has also been, of course, some policy support to deploy technology in commercial settings and develop pilot projects in order to learn how we can extract value from the electrification of the mobility sector. But first of all, why V2G is important to monitor. V2G is particularly interesting because it will allow us to tap into a large amount of flexible capacity, which if we leave unmanaged, it can actually threaten the stability of the power grid. But who will tap into this flexible resource? This is a key question, and this is what I mentioned in the V2G and all the activity going on is interesting because there are so many different kinds of stakeholders involved in this. We can include regular consumers and commercial and public fleet owners who own the flexible assets in this case, electric utilities who provide the electricity to power the EVs, grid operators who need to support the growing charging infrastructure connected to the network, automakers and equipment manufacturers who develop the hardware, and even emerging or new energy service providers like oil and gas companies who are aiming to keep market share and deliver energy to the mobility sector, no matter what fuels it or what powers it in this case. So this is a very complicated landscape. And this has pushed for a diverse group of companies to form partnerships or consortia with many purposes. And a key one is being to gain understanding of where each of them can play a role, where they fit, and what products and services should they deliver to take advantage of this opportunity. The key event that I'm highlighting here today is the joint venture between Honda and Mitsubishi Corporation. This new joint venture is called ALTNA. And ALTNA will include, among others, a smart charging service to optimize cost and the use of electric vehicles. So this service will potentially, and I think definitely, expand from optimizing charging events to maximize the use of renewable electricity and reduce charging during peak events so that we reduce stress on the grid, to provide services to the grid with bidirectional charging, or V2G. So yeah, what should you be watching out for? So as we see the growing numbers of EVs hitting the roads, we will also see a higher impact on grid reliability and energy security. So regulators will be seeking for cost-effective ways to minimize the damage. And this is where we're going to keep seeing more and more consortia partnerships of these different types of stakeholders trying to figure out where they fit, because there's still not a clear role for each of these. So the opportunities are there for everybody to figure it out. Yes, still.
So, as you pointed out, automakers and utilities are, I think, pretty entrenched in this space already. What should fleet operators be doing? Because it seems like the pressure's on them now, or the time is right for them to get involved. How should they be engaging with this space?
Yeah, for fleet operators, there is a good opportunity for them to, as I mentioned, not only do smart charging, like minimize costs for them to charge their fleet, but also generate revenue by providing grid services. So if they participate in pilot projects, and this is one of the use cases that we identified as being the best fit for V2G today, they will be able to figure out how much money they can make out of this investment that they're making, and their role in the future now that the energy markets are evolving.
And what about consumer V2G? It seems like that's still kind of further away than this more fleet-focused V2G.
Yeah, consumer V2G, I think it is incredibly interesting, but it's the most challenging in my opinion, because here you have to engage with multiple users. You have to be aware that the use of the vehicle is just different. And it could be that when the vehicle is available, let's say when everybody goes back to work at whatever hour they go back to home from work, when is the vehicle going to be available? Is it going to be plugged in? What is going to be the state of charge? And is the grid in need of whatever the vehicle can provide? In this case, it could be that you just use smart charging and reduce the stress on the grid. But it could be that maybe the vehicle is able to provide some relief to the grid. So this is definitely some interesting use cases there. And I do think that energy retailers have been actively looking into it, particularly in the UK. Like one example is Octopus Energy. They actually released a V2G tariff. So to incentivize kind of like the usage of electric vehicles and bidirectional chargers to help grid congestion and other issues.
All right. Well, Jessica, thanks so much. I'm now going to invite my colleague Varsha to talk to us about biomanufacturing.
Yeah, thank you so much, Anthony. Hello, everyone at the audience. I hope everything's going well. So let's talk about biomanufacturing. So as most of you may already know, it isn't a new technology. It's been around for a little over 2 decades. But before that, let's take a step back and see what biomanufacturing is. So it's a process to produce bio-based chemicals via biological processes using microbial strains. And I'm particularly highlighting this technology given that over the past few years, but also in the first half of 2024, investors have shown an increasing interest in biomanufacturing as the field has emerged from niche to mainstream in the eyes of academics and industry. And some very interesting companies like Genomatica, Global Bioenergies, Solugen, and Zymochem, they have secured significant funding to scale their technology and for market development. But if you look at where biomanufacturing stands today, it's predominantly in the development stage. And I think beyond funding, availability, regional policies play a key role, and so does government support to incentivize these technologies to support scalability and commercialization. So in the next coming months, folks in the audience should closely monitor global policies as they will be crucial to enhance the growth of biomanufacturing technologies, to replace incumbent materials that are regarded with high greenhouse gas emissions, beyond just consumer demand for clean ingredients in consumer and personal care and brand commitments to decarbonize. I think a good example here is a region like North America, for instance, recently renewed interest in the bioeconomy and is leading investment in biotechnology and biomanufacturing infrastructure. So here is where benefiting startups that are looking to develop novel processes and products will be able to tap into more supportive policies and regulations.
So, Varsha, you called out a couple different applications here: textiles, cosmetics, personal care. Is there one in particular where you're expecting a lot of activity this year or that you think is really promising?
Yeah, that's a good question. I think cosmetics and personal care is definitely an application area where we are seeing a growing interest from biomanufacturing companies. I think this is more from the consumer demand for more sustainable alternatives to some of the conventionally produced ingredients in cosmetic formulations, but also more so the Gen Z want to be all TikTok famous with, talking about using more bio-based, more sustainable products in their day-to-day makeup routine and ritual, right? So I think that's one space that we will see growing interest for biomanufacturing technologies.
And what about textiles? Because that's not maybe a traditional area of focus.
Yeah. So for textiles, I think the issue around microplastics is pushing brands like Lululemon, for example, like the companies like Lycra, to really explore different bio-based material producers out there. Like, for example, Lululemon has partnered with Genomatica to produce bio-based nylon. And we have Core, which is a joint venture between Cargill and Helm, that has partnered with Lycra to commercialize bio-based BDO for spandex application. So I think if you were to put it in order, I would say cosmetics and personal care would go first in terms of biomanufacturing technology adoption. And later on, textiles would also be a major application focus for biomanufacturing processes.
All right. Well, Varsha, thank you so much. I'm now going to invite my colleague Josh Haslam to talk about CRISPR gene editing.
Yeah, thanks, Anthony. So, we're in really the first decade, I would say, of really commercialization of CRISPR and gene editing applications. And what I want to talk about is actually moving beyond precision medicine, though, right? There's a lot of applications of precision medicine, but remember, for gene editing, what we're talking about is something that binds specifically to DNA or other target molecules, and you have some sort of enzymatic function tied to it, right? But that could be, cutting DNA. It also could be helping to monitor and sense something. And so, when it comes to traits, we're already seeing actually quite a bit of interest in developing markets, and to that end, actually products making it to market. Sonatech Life Sciences, you see the tomato on the right side of the screen here. They've already released a tomato that is enhanced with a molecule called GABA. And this happened in 2021. And that GABA molecule, gamma aminobutyric acid, is actually a neuroinhibitor. And what it does is help reduce stress. It can also reduce blood pressure. So, this is something that is actually, pretty well understood, well tied to consumers. Now, what don't we know yet? We don't know, how many tomatoes you necessarily need to eat to reduce stress. But the reality is we're tying an idea of food as medicine to a whole food, right? Ingredient that's been purposely developed to the market. And now Sonatech is expanding in 2024 the market after really good uptake of the product. So, we're seeing some really good momentum that way. And it's not just about those traits. We're even seeing genetically modified things get eaten. Norfolk Plant Produce has produced a purple tomato. I actually have it in my garden at home. So consumers are eating these things, and they sold out this year too. So it's another great example of not just gene editing, but these changes, right, to our food system that people are really beginning to uptake. And in addition, it's not just about food; it's also about the sensors that we use to understand ourselves. And to this end, we even see companies like Ginkgo Bioworks getting in here. They recently acquired a company called Proof Diagnostics, which developed a CRISPR-based gene editing platform. Now that acquisition is more tied to precision medicine, but one of the companies that holds a lot of the IP in this space, Sherlock Biosciences, they also recently acquired a company, and that company is called Sense Biotechnologies, and it allowed them to produce the test you see on the screen on the right, which is a COVID-19 rapid detection test that's much more accurate for at-home use and even clinical use. And so what we're likely to now see is these CRISPR devices finally achieving this agile, rapid, cost-effective diagnostics, which could very well expand broadly and cause a moment where we have, medically beneficial foods gaining traction and aligning to an increased ability to detect a lot of different things in people's lives. And so, in the future, really we have gene editing moving beyond, right, just traits and really beginning to make an impact. And we see, the sign was hesitant, I think, but what we do see is early adopters are quite interested in this stuff.
So Josh, I mean, it's still a kind of a long way to go before we all get, the pizza sauce that chills you out, right? So like there are these early adopters, but you're one of them, but you're a bit more educated than the general consumer. I mean, do you really think that, like, given the context of anti-GMO laws and political backlash, like, do you really think there's an opportunity for mass adoption here?
100%. Particularly, I mean, for the food system, CRISPR's already playing a role. I mean, we can, outside of what I brought up here, you could talk about disease risk. Bananas are a really good example. So there's already traits coming through, and I've actually seen a lot of patents coming through recently for gene edited traits. So that's happening now. Yes, policy is a challenge still. We want more flexible policy, but that's also improving. It's improving annually, to be quite honest. So we're moving in the right direction. I think there's a lot of encouragement, and as I said, the most interesting thing is that we're moving beyond research for the sake of research and research for real market potential.
All right. Well, Josh, thank you so much. And now I'm going to invite my colleague Akshay Chaudhary to talk about foundation models, particularly for advanced robotics.
Yeah, thanks, Anthony. And I just hope that people are not bored hearing about AI or generative AI.
We couldn't escape it. We couldn't do this. We couldn't do this presentation without talking about AI, I think.
Absolutely. Yeah, I think, what we have seen for the last 2 years is basically numerous applications for large language models, and especially use of ChatGPT in various industries. And we have seen executives already exploring implementing generative AI use cases across their organizations. So, running a lot of pilots and exploring how it can improve or increase the productivity in their organizations. So similarly, we have seen a lot of interest from industrial sector and how the generative AI can help them, especially in the advanced robotics. And one of the cutting edge examples of this advanced robotics is humanoids. Basically, humanoids are robots that mimic human actions as well as behavior. So there has been always an interest on how we can use these humanoids on the factory floors. So this is not new. We have seen companies like Boston Dynamics and others develop humanoids in the past, but the adoption of this humanoids were limited, I mean, slow in general. And one of the reasons for that was how these companies were training these humanoids. So basically, they were using physics-based simulations and simulating specific use cases and then training those robots for those specific use cases. But the challenge there is how many different use cases can you simulate and how well the robots can be trained with this method. So now what we see is the new set of startups like, let's say, Figure AI, Agility Robotics, UBTech, even some of the early stage startups like Physical Intelligence. They are adopting a new approach. Basically, they are going AI first. So in this approach, they will collect a lot of data from the factory floors and use that data for training the foundation models for robotics. And the hope is basically because you are training this models using the real life data, it will basically lead to a better model and much more generalized use cases for these humanoids. Of course, there are a lot of challenges. So the first one is basically there is lack of clear definition how this foundation model looks like. There is no framework as such for the foundation models. And also, at this point, there is a lack of data because there are not enough humanoids deployed on the factory floors. But the hope is that as the companies deploy these humanoids and other advanced robots in the logistics, automotive sectors, data will accumulate. And with the help of this data, they'll be able to better train these AI models. And in the next 3 to 5 years, we hope to see better, more generalized use cases for the humanoids. So we'll be watching this space closely for the next 2 to 3 years.
So, you talked about humanoids, but I think these models are potentially applicable to other types of robotics as well. What are you seeing in terms of the near-term impacts around, these new AI approaches, these AI-first approaches?
I think one of the interesting examples what we are seeing is how the existing LLMs can be used for programming the robotic arms or other robots. And basically what it is doing is it's reducing the expertise required for programming this robot by basically allowing users to interact with this software and with this robot through natural language. So the near-term impact is basically through these co-pilots, which will help the users, which will make it more democratized to use the existing robots.
All right. Well, thank you, Akshay. And I just want to highlight here, this is our Lux Tech Signal. This is our benchmark of innovation activity. It combines data on patenting, publications, funding, and a number of proprietary data sources to give a sort of relatively comparable benchmark of innovation activity across the space, right? And what you can see is that I think this really reflects a lot of the key talking points from our analysts, where we have CRISPR-Cas9 at that highest 0.70. That's really beginning to be mature. V2G in biomanufacturing increasingly mature, right, in that 50s range. And then humanoid robotics and white hydrogen. You can see they have a very different trajectory. Humanoid robotics, there was this big spike in interest in 2016, 2017, really coinciding with a lot of the hardware development, right? That's when we saw cheap robotic arms come to the market. But as Akshay mentioned, there were limitations there, really software limitations. And now we're beginning to see these limitations be resolved, be turned around. And white hydrogen, you're really seeing a pretty sharp spike up, particularly the preliminary data from 2024, which isn't included in this chart, really shows that innovation activity is heating up in these spaces. So you can see that this data-driven approach really aligns with the timeline and the trajectory of our analyst predictions, and it's a useful tool to kind of help confirm what we've been talking about in these spaces. With that, I just want to leave you with a few key points before we open up for questions. One, what's old is new again, right? I think we've seen a couple of these technologies. There are these established approaches that are having a renaissance, right? Whether that's growing consumer acceptance, whether that's new policy, whether that's supporting technologies like AI. One risk, I think, is that innovation teams tend to look at a technology, evaluate it, and then their opinion of it is fixed. And so I encourage you to go back, look at some of these old technologies like robotics, and really reevaluate where they are today and what's possible with them. Secondly, I think innovators are getting smarter on risk. We're now in this era of higher interest rates, as we mentioned. It's a bit more challenging to raise money. Companies are finding ways to manage risk, right? They're leveraging policy support. They're making more acquisitions of other startups to complement their technologies and to de-risk, some of their approaches, right? They're targeting applications a bit more carefully. And lastly, I think the next 6 months are really critical. We have a lot of uncertainty right now. There's uncertainty in the macroeconomy. Is the U.S. going to continue to slow down in terms of the macroeconomy? What about the U.S. and China, the Chinese economy, Chinese demand? We have a lot of political activity, big elections that are happening or will continue to happen, potential policy changes globally. So the ecosystem, the environment needed to support these technologies, it's going to change a lot in the next 6 months. And the next 6 months is really going to determine the trajectory of these approaches. Are they successful? Are they going to crash and burn? We're going to have to wait and see. And that's what we're going to be watching for over the next 6 months through the rest of 2024. And you'll hear an update from us as we do our year-end webinars and our year-end review on everything that happened in the rest of the year. But with that, I want to thank you. I would like to say that we're now going to open the floor up for questions. Again, you can type them in that questions box. I'm going to ask all of my colleagues to come back on video. Remember, if we don't get to your question on this call, someone from Lux will be in touch after the webinar. So first of all, thanks everyone. Thanks to my presenters for sharing their thoughts. My first question, this is the top technologies webinar. But for my own interest, are there any bottom technologies, technologies that you think are not going to work or are going to have a rough time in 2024? Jess, we chatted about this earlier, so I'll call on you first. Is there a technology you'd like to call out as going to struggle this year?
Yes, and maybe this will generate a bit of some commentary from the audience. But I do think that something that is overhyped for utilities in particular is the use of Gen AI. It seems like everybody wants to be using Gen AI for something they do not know what, but they know they want to use it, or they feel like they need to use it. And this kind of reminds me of a few years back when blockchain was everywhere. So utilities were like, we need to use blockchain. But why? They had a solution, so they were looking for a problem. And there were so many different pilots that made absolutely no sense because they just felt like they needed to use it. So in the end, there aren't that many utilities today that actually use blockchain for anything. Yeah. But they did try it out, so maybe this is what will happen. We'll see a lot of crazy pilots of using Gen AI for maybe for some retail-oriented things like customer support and stuff like that might be something that will stick. But other than that, yeah, there are very limited use cases where I see Gen AI will add value to the utility sector and not overcomplicate things with a technology that probably is just too complex and replacing something that already works, or it's not working today, but there are alternatives that are available that can address the same issue.
Thanks, Jess. Any other lowlights from the group? Okay, we have a number of questions in the chat here. One theme that's coming up in the questions a lot is regulations, and in particular, some questions about hydrogen policy, Renil, and the way white hydrogen would maybe interact with tax credits or other things like that. Can you just say a few words about, where white hydrogen fits in the policy space?
I think I think white hydrogen actually stands to gain a lot when it comes to the policy space, depending on where you are in the world, of course. So if you're in the US, for example, where you can benefit from the IRA credits. Now, the IRA credits, they don't discriminate on where the low carbon hydrogen comes from, as long as the carbon intensity of that hydrogen is lower than that of fossil hydrogen. Now, natural hydrogen would technically have the lowest carbon intensity among all the other options for low carbon hydrogen, because you don't need electricity, you don't need high temperatures to convert a product into low carbon hydrogen. So from a policy perspective, white hydrogen or natural hydrogen actually stands to gain a lot because it will have a much lower carbon intensity. Now, I think that doesn't mean that if you were to find natural hydrogen, then you will suddenly be successful in the space. I think regulations are certainly important, but you also need to find a customer for your low carbon hydrogen. And this is the challenge with the entire hydrogen economy today, is that you can produce low carbon hydrogen, yes, but you need to find someone to sell it to, and that person has to be willing to pay a higher price for that low carbon hydrogen compared to the fossil hydrogen that they're buying today. And this is something that natural hydrogen will also have to overcome. So I would say from a policy perspective, yes, white hydrogen is a great option. However, you still need a customer for that hydrogen.
Okay. If there's any other comments on regulation?
Well, I would say, one thing just to add is, we do see regulations coming to target innovation somewhat too. I know there's some really interesting conversations right now, for instance, going around cell-based meats and the competition between, existing markets, agriculture, right, and innovation. And we've seen states, let's face it, make some really interesting decisions about potential bans on cell-based meats, right? And this is a new trend for sure, to put innovation in that regard into the political paradigm. And we'll see if that continues. So I'm really interested to see how that interaction between an established industry and an emerging industry that clearly is aimed at disrupting one plays out as we balance rural industry, urban industry, right, and different well-beings and livelihoods. So there's some really interesting commentary, I think, to come in these elections that we have upcoming.
Really interesting. You're being very kind to certain parties, I think, Josh.
That's for sure.
With that, I think we're going to conclude our webinar for today. The slide presentation and the recording from this webinar will be sent to all attendees via email today. After leaving the webinar, you will be prompted to complete a survey on today's presentation. And so we'd appreciate any feedback you have. That really helps us inform and improve future webinars. And you can also take a moment to check out our upcoming webinars. We have one in just 2 days, I believe, July 18th, the top 5 trends to watch in 2024, kind of a companion piece to this webinar. So if you've enjoyed this webinar, definitely do check that out. And then we're looking to microgrids in August. Thank you so much.